Okay, I'm live. All right, I found another app. Hopefully, this one's better than the other one. I got the stuff. Hopefully, this video will be smooth and yeah. This is another video. Oh my god, you guys are gonna hate me. All right, I'm gonna, I guess, reread again. This will be a 30-minute video. If you have something to do it now. Don't watch, because I may have to do another video because the stupid app doesn't work. So it appears that the cam is working, I think. Unless there's like hella lag. Wait. Oh, okay. All right. I thought that was like, I thought there was like some kind of lag. Yeah. All right. Let's do this. Electricity is a type of energy much like heat, gravity, or light. Electrical energy flows through conductors like wires. You can convert electrical energy into other forms of energy to do something interesting, like turn on a light or make some noise out of a speaker. The components you might use to do this, like speakers or light bulbs, are electrical transducers. Transducers change other types of energy into electrical energy and vice versa. Things that convert other forms of energy into electrical energy are often called sensors. And things that convert electrical energy into other forms of energy are sometimes called actuators. You will be building circuits to move electricity through different components. Circuits are closed loops of wire with a power source, like a battery or something to do something useful with the energy called a load. In a circuit, electricity flows from a point of higher potential energy, usually referred to as power, or the positive symbol, like the plus symbol, to a point of lower potential energy. Ground, often represented with a minus symbol, or GND, is generally the point of least potential energy in a circuit. In the circuits you are building, electricity only flows in one direction. This type of circuit is called direct current, or DC. And alternating current, AC, circuits electricity changes its direction 50 or 60 times a second, depending on where you live. In the US, I think it's 60. This is a type of electricity that comes from a wall socket. So that tingling feeling you feel when you put your fork inside the wall socket, that is, AC current flowing through your body, and it's changing its direction 50. No. Since you're in the United States, it's 60 seconds, 60 times every second. So there you go. There are a few terms you should be familiar with when working with electrical circuits. Current, measured in amperes or amps with the A symbol, is an amount of electrical charge flowing past a specific point in your circuit. Voltage, measured in volts with the V symbol, is the difference of energy between one point in a circuit and another. And finally, resistance, measured in ohms with the ohm symbol, omega symbol, and how much a component resists the flow of electrical energy. One way to imagine this is to think about a rock sliding down a cliff. So I'm going to show you guys. I don't know if you guys can see that or not, but one way to imagine this is to think about a rock sliding down a cliff as figure. Where's my pencil? Holy. Holy macaroni, where is my pencil? I need a pencil. Should have one in my like backpack or something. Oh, there we go. Okay. The higher the cliff, the more energy the rocks have when they hit the bottom. The height of the cliff is like the voltage in a circuit. So this is like, hope you guys can see the whole diagram. So this right here, this height is the voltage. Your current is going to be the amount of energy that voltage, that height gives to the rocks as they're running down the hill. And your resistance is going to be the jagged edges of this hill that keep the rocks from falling down. So the height of the cliff is like the voltage in the circuit. The higher the voltage at the energy source, the more energy you have to use. The more rocks you have, the more energy is being carried down the cliff. The number of rocks is like the current in an electrical circuit. So bunch of rocks, bunch of current. The rocks go down through bushes on the side of the cliff, losing some energy in the process. So some rocks get stuck in like a crevice in the side of this, causing there to be less current towards the end. The losing some energy in the process, the energy is used up to crush the bushes. The bushes are like resistors in the circuit, offering resistance to the electrical flow and converting it into other forms of energy. Okay, so this is the diagram once again. You have your voltage, which is, the cliff. Your current is going to be the amount of rocks you have flowing down this cliff, and your resistance is going to be stopping those rocks from reaching the exit. This is the resistance causing these rocks to not go down. I mean, their rocks do get through the bushes, though. Okay, now let's continue reading. All right. A couple of things about circuits. There needs to be a complete path for the energy source power to the point of least energy, ground. To make a circuit, if there's no path for the energy to travel, the circuit won't work. All the electrical energy gets used up in a circuit by the components in it. Each component converts some of the energy into another form of energy. In any circuit, all of the voltage is converted into another form of energy: heat, light, sound, etc. The flow of energy at a specific point in a circuit will always be the same, coming in and going out. Okay, I'm going to read that again because I didn't really understand that. The flow of current at a specific point in a circuit will always be the same, coming in and going out. Okay. Electrical current will seek the path of least resistance to ground. Given two possible paths of electrical current will go down the path with less resistance. If you have a connection that connects power and ground together with no resistance, you will cause a short circuit. The current will try to follow that path. In a short circuit, the power source and the wires convert the electrical energy into light and heat, usually as sparks or an explosion. If you ever shorted a battery or seen sparks, you know how dangerous a short circuit can be. Okay. Don't put your fork in the toaster. Got it. Okay, now we're going to learn what a breadboard is. So I'll pull out my handy dandy Arduino and my pencil. And it says, what is the breadboard? The breadboard is the primary place you will be building circuits. The one that comes in your kit is solderless. So named because you don't have to solder anything together. Sort of like the Lego in electronic form. The horizontal and vertical rows of the breadboard are shown in figure 3 through. Okay, so now I'm going to show you how these things are connected. Alrighty. So you have a positive, you have a negative. There's a strip of thin metal that connects this whole row. They're internally connected. However, this row, this positive row is it's separate from this row. From, this whole row is connected internally like a metal slab, but it's not connected on this side. It's negative side. And the negative and positive, there's no electrical current going through any of this. They just labeled that so when you put in your wires, you won't put your ground with your positive or your high potential. So you know. Now here they are horizontally interconnected. So from here to here, they're connected. They're connected between this point. From here to here, they're connected. You can use a jump wire to connect these. But going down, they are connected as well. But from here to here, they're not connected. I can show you this diagram they have. Hope this kind of helps. This is what I was talking about. You could pretend like this is the positive, this is the negative. They didn't label it here because, they're just showing you the internal, like how it looks like internally. So you have your thin piece of metal here, thin piece of metal here. They're not connected. Here they're connected horizontally, but these two are not connected. There's a big gap in the middle. But yeah, they're just showing you how it looks like. This is a breadboard. Boom. So let's get to it, ladies and gentlemen. We're about to build our first circuit. Okay. Throughout these projects, you will see two views of circuits. One in breadboard view, and the stuff that looks like in your kit. And then the other one is schematic view, which is going to be right here, ladies and gentlemen. This is your schematic view. This right here is your breadboard view. All right, which is more abstract and showing ways the relationships between components in a circuit. Schematics don't always show where components are placed relative to each other, but they show how they are connected. Okay, your first components. So this is what we're going to do, ladies and gentlemen. We're going to need an LED, a resistor, and a switch. An LED, light emitting diode, is a component that converts electrical energy into light energy. LEDs are polarized components, which means they only allow electricity to flow through them in one direction. The longer leg of the LED, right here, is called an anode. It will connect to power. The shorter leg is called a cathode and will connect to the ground. So cathode, anode. When voltage is applied to the anode of the LED, the cathode is connected to ground. The LED emits light. So you have to make sure that's on correctly, because if it isn't, you will not get any light. I have an example of LEDs right here. It's Christmas, so I bought some. Turn the light off. Show you guys. Doop. And here we go, ladies and gentlemen. LED lights in the real world. Here's a good example. Okay, I'm going to turn those off. All right, let's get back to the lesson. Okay, now a resistor is a component that resists the flow of electrical energy. See the components list for an explanation on the color stripes on the side. So resistors have colored stripes. These stripes have values, and they let you know how many ohms that this resistor has, or how much resistance it has. Okay, it converts some of the electrical energy into heat. If you put a resistor in series with a component like an LED, the resistor will use up some of the electrical energy, and the LED will receive less energy as a result. This allows you to supply components with the amount of energy they need. You use a resistor in series with the LED to keep it from receiving too much voltage. Without the resistor, the LED would be brighter for a few moments but quickly burn out. All right, we need resistor so it won't explode in our face. A switch, this thingy, interrupts the flow of electricity, breaking the circuit when open. When a switch is closed, it completes a circuit. There are many types of switches. The one in your kit are called monetary switches or push buttons because they only close when pressure is applied. All right. So we have our schematic view of how, I believe, this side right here. So these two pins of a switch are connected to each other. So this little switch here, these two are connected, and it acts like this. So it acts like I guess that's just a toggle switch. So I guess you press it and it'll stay pressed. It'll stay pressed down. And I think if you press it again, it'll open. I'm not sure. These two are not they do not form the switch. So from this side of the button, from this side of the switch to this side, they're connected from here to here. Oh, wait. Holy crap. I think my camera froze. Frick. It's still going. I'm not sure why. Dang. I'm so sorry, guys. I didn't even notice. I'm just gonna continue. I've made so many streams. You know what? I just read the theory, so I'll just make another video that's me building the thing. I just read all the theories, so now I'm just gonna build the thing. So I guess I'll end stream. Your stream will immediately stop, and you will no longer be live. End.